Many Docker tutorials assume you are a developer. This one is a bit different. We're going to cover what containers actually are, how they compare to virtual machines you already know, and how to get Docker running. Let's get into it. Containers are an innovative way to package software into an application. You can think of containers as a bundle of libraries, dependencies, code, and whatever else an application needs to run, all wrapped together. Because everything the application needs to run is already inside the container, you can take that container and run it on a desktop or server without needing to install special dependencies or worry about getting the right version of this library or the right version of that dependency. And we avoid the old excuse we've all heard before. It works on my machine, it must be a problem with yours. When we use containers, it works on my machine, your machine, all machines. This small bundle of software also makes containers very efficient. They start up and shut down very quickly, sometimes in less than a second. This also makes them very scalable. Need to handle more load? Spin up more containers. Traffic drops off? Scale them back down. And containers run independently. They are isolated from each other. Sure, they can communicate with each other, and they do share host resources, but one container won't interfere with the operation of another. This is just the start of understanding what containers are and what they can do. Stick with me and we'll get a much deeper understanding of them. There is a misconception that containers are just a lightweight virtual machine. Let's clear this up right now. When we think about VMs, we think of a model like this: a host with an OS and a hypervisor, virtual hardware such as CPU, memory, and disk, then a virtual machine which has a full operating system installed, and one or more applications installed within the operating system. So a virtual machine virtualizes an entire host. A container, on the other hand, works differently. There's no hypervisor and no virtual hardware. In some cases, a container might look like it has its own full operating system. This is because they often contain some components that are common to operating systems, such as a command line, shell, or terminal. However, there's one really critical difference between containers and a fully self-contained operating system. And that is, a container does not have a kernel or a bootloader. The kernel is probably the most important part of an operating system. It manages hardware, allocates resources, provides security, runs processes, and so much more. Containers use the host operating system's kernel directly. This is what makes containers so lightweight compared to virtual machines. There's no independent kernel, no hypervisor, and no virtual hardware. So while a virtual machine virtualizes an entire host, a container only virtualizes an application. This is the critical distinction between the two. The container is isolated on the host, so it doesn't interfere with other containers or other applications running on the host. Each container thinks it's the king, the only process on the server. In reality, the kernel tricks them by placing them in isolated locations where they can't see each other. But containers can still communicate with each other when we want them to. We'll dive into that a little bit later when we talk about Docker networking. So, do containers replace virtual machines? No. While they're similar in some ways, they serve very different purposes. In fact, a common setup is to build a Linux virtual machine and then run containers within the virtual machine. These two technologies complement each other, rather than competing with each other. So how do we actually run a container? For this, we use a container engine. This is the software that starts, manages, and stops the container on a host. There are several container engine options available, such as Docker, LXD, Podman, and others. We're going to focus on Docker in these videos, as it's the most widely used option. It's what you're most likely to encounter in the real world. To get started, I recommend that you download and install Docker Desktop. It's great for getting started and it runs on Linux, Windows, and Mac. Docker's website has everything you need. The download link and install guides for each platform are shown on the screen here. If you want to set up a full production environment rather than just a local machine for learning and development, you'll want to use Docker Engine instead. This is the full server edition of Docker. Just be aware that this is installed on Linux only. Now, a quick note on Docker Desktop if you're using Windows. Docker is made for Linux. When running Docker Desktop on Windows, it will use WSL2, that is, the Windows subsystem for Linux. The Docker Desktop installer handles all this for you automatically, so there's nothing extra you need to really worry about. In the following videos, we're going to look at the fundamentals of running containers in Docker, how it handles storage and networking, how we can create our own custom containers, and how multiple containers can work together to deploy robust applications. And if you want to go deeper, I've built a full Docker course specifically designed for the network engineer's mindset. It contains hands-on labs and real-world examples. The link is in the description.